Water is the most urgent issue that DALA facing nowadays. Different sources of water are chaotic in the existing water cycle. Untreated drinking water collection, direct surface runoff, and discharged black water causes the flood and pollution in the ditch and river. Among the drinking water issue and lack of perception of water sustainability is a fundamental and interrelated problem which form my focus. Drinking water system in DALA is vulnerable. People can get water through limited tube wells and expensive bottled water in water shops. However, the most fundamental way of getting water is from the lotus ponds. In the rain season, ponds and streams are usually saturated. Interestingly, the school location is scattered but correlated with these ponds. Small ponds were digged by schools to reach self-sustain. However, most of small ponds in school are dry out because of the low capacity. Generally, drinking water issue seems not yet get enough attention from the YCDC government. No development plan in existing urban DALA, and a water treatment plant is far away. Therefore, these issues form my design goals. Instead of single functional zoning plan, I propose to mix the water filtration and education by using terraced wetland, so that urban DALA can be a pilot water educational center using its strengths that attract kids from the central Yangon, and connect the rest of the developing area, research center, and universities to form a sustainable water education industry. Facing the increasing population, it can improve the quality and capacity of potable water and provide water sustainable education for future generations. The detailed design strategy is change the original flat topography and homogeneous ponds, create different levels and functions of ponds to form terraced wetlands as a drinking water filter, as well as flexible educational playgrounds in terms of different water levels. In normal days, the rainwater is collected by channels and pores and stored in the underground tanks or central reservoirs. This flow of water is designed to generate the power. The stored power supplies to water cleaning mechanism is self-sufficient. In rain season, the terraced wetland system can hold more water. In dry season, the central reservoirs keep watering. Other terraced ponds that dry out can be extra play spaces for children. Therefore, in order to apply this typical section, several locations can be chosen. Among, a pilot area was chosen to do the detailed design. There are two types of terraced wetland. First is salty water wetland near the riverfront. Different salty tolerance plants are used to filter extended seawater. Channels are designed to separate the salty water, flood back, and collect water for domestic use. In the center, there is a freshwater wetland system, including different functional ponds. The entire water cleaning process takes about 8 days. The rainfall was firstly collected in the upper sedimentation pond directly or from the proto-remediation edge through the surface runoff. After the precipitation, it is going to transfer to the water aeration ponds through shallow water treatment channel, and finally it will be stored in the central reservoir. By this design, the total water collection capacity will increase about 5 times. In order to make the water treatment process a public education, the whole water treatment is designed to be observed by children through different types of platforms and activities. For example, in normal days, in shallow water treatment channel, children can experience the water and learn the functional local plant species. In the dry season, low-level ponds can be reused for playground with green ecological buffer. In the rain season or extreme weather, elevated observation room can still be used for education. After the pilot design, terraced wetland strategy can be applied to other similar places in 5 years. It is low cost and can be self-sufficient to solve the urgent water issues in community scale. In the 10 years, individual sites can be connected with planned water plants and reservoir and local pipe system. In 20 years, when DALA is connected by city-type water, these terraced wetlands can be preserved as parks and connected by green and blue system, which enlarge the ecological function. To summary, it is anticipated that with the future population growing and construction in DALA, this wetland can be a landscape framework to guide the city growth and increase the perception of used water. In the end, contribute to the capacity building of the DALA.